the underlying file system. So this will generate errors invariably. So one safe way of doing this is rebooting to run level 1 mode, where you have exclusive access, and then resizing it, or moving your data off to some other location and then redoing it altogether. This could go on and on forever, which is why reducing the file system usually proves to be more problematic than extending it or increasing it. Let's just quit altogether. Now let's try to remount the file system to see if it mounts, and it throws an error at this particular point because it knows that there are inconsistencies with the file system. So we'll leave it offline and continue our work. So resizing usually works better in the upwards direction. Reducing is a bit trickier, but can be performed, and in worst case scenarios you may have to recreate the file system on the resized partition presented by LVM. So note, reductions will likely return errors resulting in re-provisioning of the FS. So resizing is one feature. Another feature is the ability to rename a volume. Supposing the volume began its life as a var container, such as log_vol var, and then has morphed as a consequence of different needs by your users to, let's say, something to store data for applications such as an opt tree or what have you. The ability to rename the logical volume or any of these LVM components is rather important. So rename logical volume. And similarly, there is a rename command named lv_rename. This allows us to change the name from an existing name to a new name, and it takes the syntax of volume group name followed by old name, then new name. The volume group name is vol group var. The old name of the logical volume is log_vol var, and supposing we wanted to make this perhaps log_vol opt to mount, let's say, the opt mount point. This would allow us to rename the logical volume, not the volume group, but just the logical volume. Let's try this, and renamed log_vol var to log_vol opt in the volume group vol group var. If we now LV display, you'll see the new name of the logical volume, although it's currently not accessible because of the changes to the size. If we reset this to 6 gigabytes, it would probably mount without an issue. We'd have to use LV, of course, to resize it, LV resize. So now it's called log_vol opt, and if we look in the dev tree beneath vol group var, the object has been renamed, and it points to dm-2 and can be mounted as such. Let's take a look at the root of our file system. Indeed, there is an opt directory, but it's empty, so we could mount to that particular mount point. Let's change the size of log_vol opt using LV resize, setting it now to its original size of 6 gigabytes, and this should resize it for us. We'll then LV display dev vol group var log_vol opt, and it's now set to 6 gigabytes. Now let's try to mount it to the opt mount point. And let's echo the exit status, mount, and indeed we appear to be back in business. So it's there. So we had some discrepancies between the superblock size on the file system versus what was presented by LVM's partition, and that caused the friction or problems with reducing the volume initially. But if you simply reset it to the original size, then there doesn't exist a discrepancy. But again, you could work around this by going to single user mode, ensuring that the volume is offline, and then mounting it accordingly. Now, of course, this means that FS tab should be updated to reflect the new mount point. because one, the volume is no longer called log_vol var, it's called log_vol opt, and two, it's no longer mounted at LVM var1 but rather opt. Now you can mount your device anywhere you'd like and it would work, but it should match, should reflect the natural order of things, so the names should coincide. Now supposing we wanted to rename the volume group, that's also possible. Let's just note what we've done here. LV resize, restoring it to 6 gigabytes, dev vol group var /log_vol opt. This restores it. So restores to 6 gigabytes and renames volume, not volume group. And if you'd like to rename the volume group, there's also VG rename. So 5, rename volume group using VG rename. Let's tab it out. VG tab, and there are the various commands, including VG rename. So VG rename with help shows the ways in which you may run it. You specify the old volume group path and the new path. So for example, VG rename, and the old name is vol group var, and supposing we wanted to call the new name vol group opt, for example, it searches and appears to have run successfully. Notice we didn't have to specify the full path. Let's just copy this and it'll be placed into our notes, but let's VG display nonetheless. And there's the original volume group created by the operating system during installation. And here's the new vol group opt, which means we'll have to update our etcfs tab to reflect this change. So renames the volume group so that it's more apropos, and that's now in place. So B, update etcfs tab to reflect volume group name change. So with that said, let's find this root shell and nano etcfs tab, and we'll find its location and change the name of the volume group from vol group var to vol group opt. And to test that things are working, let's umount /opt, and it's currently not mounted. We can also grep to check. Nothing's there. And let's mount -a, echo the exit status, and remount, searching for opt, and now it's back. So it's available, and df-h should reflect that it's 6 gigabytes. So the storage that began its life for var now services /opt, which means if any data existed on the original mount point, log_vol var or log var LVM var1 would now become part of /opt. So you wouldn't lose data as a consequence of renaming the logical volumes and or the volume groups. You're simply reallocating, which is rather straightforward. Now what if you wanted to assign more storage to the volume group? So supposing, let's VG display vol group opt. This volume group is 8.23 gigabytes, which let's say isn't enough, and we've grown beyond this capacity. So in order to provision additional storage, you'll have to repeat the process of generating an LVM partition. So an LVM partition is needed, and then it needs to be assigned as a physical volume, which makes it a member of the logical volume management environment, and then it needs to be associated with a volume group. So a few steps are required. So our sixth task here is to assign more partitions, which really means more storage, to LVM for management. So the steps should be quite familiar now. You use a tool such as Parted to manipulate one of the disks, such as dev SDC, to add additional storage. So Parted, and then we're going to make part once we're in to make a new partition, and we'll determine momentarily whether or not it'll be a primary or extended partition, but let's assume it'll be primary, and then we'll determine where it begins and where it ends by enumerating the